All right, so just to go back and refresh, as part of a survey, students in a large statistics class were asked whether or not they ate breakfast that morning. The data appears in the following table. Is there evidence that eating breakfast is independent of the student's gender? Test an appropriate hypothesis. Give statistical evidence to support your conclusion. So we found the expected values. So these are the expected ones over here. What was given to you was the observed values. So we're looking for evidence that eating breakfast is independent of the student's gender. So what would my hypothesis, my null hypothesis be?
That eating breakfast is
No.
yeah.
That it is.
Yeah, that it is like independent of
Yeah,
breakfast.
no change. So is independent of gender. What's the alternate?
That it's not.
Yep. Eating breakfast is not independent of gender. All right, assumptions. All right. Is it counted data?
Yes.
Yes.
Oh, that's what it's called, assumptions.
It's categorical, so yes. Eating breakfast is not something like that has a number assigned to it. It's a yes or no question. Is it random or at least representative? Yeah. Yeah, it is representative.
Yeah, so what's the difference between representative and random?
Usually if it's random, it'll say it's random. I mean,
Yeah.
to be totally honest.
Or it'll be like we pulled like or questioned random students, whereas this one says in a large statistics class. So you can assume that they're representative of like all the classes, kind of. Are all the expected values greater than or equal to 5?
Yes.
Yep. So we can proceed with a chi-squared test for independence. So, do we need to see these all written out, or are we good to just plug them in?
Can I see it written out, please?
How many degrees of freedom do we have also?
3. Like 1. Wait.
Rows minus 1 times columns minus 1. 2 minus 1 times 2 minus 1 is?
Okay, so
1, yes. So, chi-squared is equal to 66 minus 76.17 squared divided by 76.17 plus 66 minus 55.83 squared divided by 55.83 plus 125 minus 114.83 squared over 114.83 plus 74 minus 84.17 squared over 84.17. And we're going to use an alpha of 0.05 again, so it doesn't specify what we're looking for, but
you talking about the chi-square test?
Mhm.
What kind of, so what would we want the round to?
I mean, probably like
Second.
2 or 3 decimal places. Probably 2, and that's normally what chi-squared is in, I think. Do we have a number?
5.34.
Do we have the p-value that goes with it?
0.021.
So 0.021. So, what do we know then?
We're
P-values
gonna
low.
reject them all.
Yep, my p-value of 0.021 is less than alpha equal to 0.05. So I reject the null in favor of the alternate. So there is enough evidence to suggest that eating breakfast is not independent of gender. Females are more likely to eat breakfast and that's just from looking at the chart than males.
How did you put the numbers in? Did you do like 2 by 2?
Yeah, the 2 by 2.
Yeah, it's just.
And you just have to do the observed.
Yeah, it automatically does expected for you. Just remember for the Goff test in the list, you have to actually type in the expected values yourself. It doesn't do it for you. Does anybody remember how to find independence from way back when?
If it's like less than 1, I mean,
Like we have like B given A and there's somewhere in there.
oh,
Like
P of A is equal to P of B, it's independent.
B giving A
A given B.
and B. Yeah.
Wow. You have good memory,
So this would be something like the probability of eating breakfast is equal to the probability of eating breakfast given female So what's the probability of eating breakfast?
.577.
How did you find that?
I took the total number of people who said yes and divided it by the total number of people in the whole
So,
class.
191 over
Yeah.
331, right? And then what would be the probability of eating breakfast given female?
Like,
125.
yeah, 125 over 331, so.
So 125 over, it needs to be out of the total number of female. Because probability of eating breakfast, given that they're female, would be the intersection of eating breakfast and female out of the total number of females, so out of 199. And if you do that, let's see, 191 over 331 was what? Josh, I think you gave it to me. 0.577, and what is the 125 over 199? 0.628. Those are not equal, so they are not independent. So that's another way that you can show independence as well. So with the same amount of information that we had however many chapters ago, we now have a different method that we can test for independence.
We could have a more complicated method to check for independence.
Or just a way to verify your answer.
Yeah.
All right, well, that's it for that.